Welcome. Today I'm going to go over using the 3-port and 5-port pressure manifold in the cardiac catheterization lab. Starting with the 3-port manifold and injector, which is the one that you hold closer to your hands. Some caveats. The system used in every lab differs. What I'm going to show you here may not necessarily apply verbatim in your cath lab. Check with your senior staff members if the long arm of the knob points towards the closed side or the open side. In our cath lab, the long arm points towards the closed side for both the 5-port and 3-port manifold, but that may not always be the case in your lab. The 3-port manifold will be connected to the pressure injector. The 5-port manifold will be connected towards the pressure transducers, which are the two electronic chips you see on the other side. The knobs of the 3-port manifold we will call V1, closest to the patient over here, as well V2 and V3. V1 is connected to the saline as well as the pressure transducer. V1 is what we connect between the 3-pressure transducer, the 3-port transducer manifold, and the 5-port manifold. So now, if I turn this knob towards the right side, there's a connection between the patient line, which is on the left, as well as the pressure sensor. Now, if I turn it off to the patient, with the long knob off to the patient, then there is a connection between the saline bag / pressure transducer as well as the injector. Because remember, the short sides are the open sides of the T valve. Now, if I have it the long side pointing up, then there is a connection between the long tube connecting to the patient and the pressure transducer / saline bag. That's how we measure pressure. For each of these, I show you a little inset of a diagram of what's happening, where the X shows the blocked. V3 is connected to air in case we want to air out bubbles or we want to perform zeroing. And V2 is connected to the pressure, the contrast bag or contrast reservoir. At all times, by default, you want to have the V1 pointing towards the right so that your default position is pressure transduction, so that you can have continuous hemodynamic monitoring of the patient, which is what we see in this picture. Now let's say we want to aspirate contrast. We'll turn V2 pointing to the left, make sure that V3 is close to air by pointing up, and then we can suck the contrast from the contrast reservoir into our syringe. When you have sufficient contrast, we can turn V2 back off to the contrast reservoir, turn V1 off to the pressure transducer. Now we have a direct connection to that long line to the patient, and we can inject as long as we have made sure that there's a safe pressure before doing that. The moment you finish injecting, we turn it back to measured pressure, which is V1 pointing to the right. Now let me go through the common steps systematically using our diagram over here. So in this diagram, you see the V1, V2, V3. You see our T-junction valves, where the long knob, which I indicated in the black, is the blocked side, which I indicated with the red cross box. Okay, so in this default position, V1, V2, and V3 all have the blocked arm, which is the long arm pointing up. So the T-junction valves all connect to each other. You now have a direct connection between the patient and the injector syringe. So the blood, which I indicated in the red arrows, is flowing freely. You can apply negative pressure by pulling back on the injector syringe to aspirate the blood. Now, once you aspirate the blood, you want to remove the bubbles that may have occurred somewhere in the line in your catheter or your IV tubing. To do that, you turn the entire 3-port manifold upside down, such that the injector syringe is at the very bottom and the bubbles rise to the top. You turn V3 to the left so that it's now open to air, and you can push out the air bubbles from the injector syringe onto the table. That's how you can get rid of the air. After you remove the bubbles, you turn V3 back off to air so that the system is closed once again. you return the injector syringe to the top, the injector syringe which is being held by your right hand, or your non-dominant, or your dominant hand, I mean. And now again, we have a closed system where you have a direct connection from the injector syringe to the patient. So V1, V2, V3 are all pointed up, and you can inject the blood forward. There are many cases where you want to aspirate contrast and be ready to inject contrast, not just blood, such as when you have engaged into a left main or right coronary artery, or when you're in the process of doing that. In that situation, you want to aspirate contrast. So here we have a V1 pointed to the right because we are continuously monitoring the patient's hemodynamics with the pressure transducer. And with the contrast is flowing through. V2, the long arm is pointing to the left, so the contrast is flowing freely into the injector syringe. You have to be sure that V3 is pointed up so that you're not accidentally sucking some air into the injector syringe. If not, you might have air embolism. Once you have accumulated sufficient contrast, you can turn all V1, V2, V3 upwards, and then you have a direct connection to the patient again, and you can inject the contrast. The moment you finish injecting contrast, turn it back to the default position or home position where V1 is pointing to the right, such that the T-junction allows the patient's pressure to be connected to the pressure transducer or the 5-port manifold. I hope that makes sense. Okay? If you have any questions, you can just go back and stare at the diagram. Now let's move on to the 5-port manifold now that we understand the 3-port manifold. In this 5-port manifold, you have V1 and V5, which are flanked by electronic chips, which are the pressure transducers you see over there that I'm holding with my left hand on both sides. V1 and V5 are connected to air. So the purpose is it allows you to zero the left and right pressure sensors or transducers, which is what I'm doing here. So if I put the V1 pointing to the right and V5 pointing to the left, that allows a direct connection to air, and that allows you to zero the pressure transducer. So now let's turn it back off to air by having the long side pointing down. We have V2, V3, and V4. V2 and V4 are connected to either the 3-pressure manifold or directly to a catheter. And V3 is connected to the saline pressure bag. So let's follow this V3 line to see for ourselves with our own eyes that that is a saline pressure bag and that the pressure is up. That allows the saline to drip forward when you have that valve open. So now you see the long arm is pointing down. We have closed the saline port. If the long arm is pointing up, then we have opened the saline port. It can flow either leftward to V2 or rightward to V4. So let's say we turn V4 up and we turn V5 to the right. The saline will just start dripping out V5. Now let's close V4 to the right. Now the saline will follow this line that connects to our 3-port manifold, and it will come out over there in the flush saline forward mode. Let's study these two diagrams over here. This is something you want to do when you want to connect a catheter with a wet-to-wet connection. So you see now the saline is coming out from V4 to the 3-port manifold through the front of the catheter. There's actually several ways to turn off that flush. You can turn it off at the 3-port manifold or the 5-port manifold at V1 or V4 respectively, or you can turn off the source itself by turning off the saline pressure bag at V3 with the long knob down. But let's turn it long knob up because we need to do other business. There are many situations when you need to have a second catheter connected, and you would plug this into V2. So let's have our saline flowing forward by having V2 pointing to the left. So the saline flows from V3 down to V2 down to this pigtail catheter. After we have done that, we have 2 catheters available to measure simultaneous pressures. You might do this if you are doing a restriction-constriction study, or if you're doing a hokum study, or the most common situation, doing TAVR. So first, you need to zero out the pressure with V1 and V5 pointing to the right and left respectively. Once you have that, then you can make sure that V2 and V4 are pointed to the right and left respectively, so that you have a pressure connection to the pressure sensors, the pressure transducers, which are the chips on the left and the right. Sometimes if you have residual contrast, you want to flush it out from V4 because the residual contrast can artificially inflate the aortic gradient, and that's what I'm doing over here. You can flush saline from V4 with the V1 in the 3-port manifold pointed down, and continually use this syringe. Now, you want to make sure that when you're done with that, you turn V4 off. If not, you're going to have this phenomenon where the syringe continually expands, or worse still, if it's in a position in the patient that you don't want. What I'm showing you here now is removing bubbles. So, like I said before, you want to turn it upside down, remove the bubbles, then turn it right side up, and then you can aspirate the contrast again. Once you've done that, you can make sure you can put all the knobs pointing up. So I'm aspirating the contrast again. And you can have all the knobs pointing up, and then you can inject to the patient, like I showed in the prior diagram. So before we finish, I wanted to go over some best practices. Make sure you zero the transducer with it positioned at the level of the mid-axillary line, which corresponds to approximately the level of the heart. If the transducer is positioned above this level, the recorded pressure will be falsely low. If it is below, the pressure will be falsely high. Next, before connecting a catheter to the manifold, always bring saline all the way to the tip of the manifold tubing first. This wet-to-wet technique eliminates any air gap at the junction, reducing the risk of air embolism. If the 2 baseline waveforms do not share the same zero line on the monitor, re-zero both channels before proceeding. Always close the saline path when you are not actively flushing. An open valve will drip continuously, waste a pressurized bag, and can introduce air into the circuit if the bag runs dry. That's all I have for you for using the 3-port and 5-port pressure manifold in the cardiac cath lab.